Hello everyone, this is Miss Lindsay. Today we're going to discuss section 15.3, combinations. Today we're going to discuss again combinations. What is combinations? Combinations is a grouping of numbers where order is not important. This is definitely different than permutations. Permutations are dealing with order, and in this case combinations are simply just dealing with the grouping of numbers where order is not important. So we call this the combination of n objects chosen r at a time. So n choose r is equal to n factorial over the quantity r factorial times the quantity n minus r factorial. Again, this is very similar to permutations. There's a slight difference, obviously. We have that r factorial is now in there. We also would write this as, it looks like it's not a fraction. We have it inside the parentheses, n over r, and again, this is read as n choose r. These are equivalent to each other, so n choose r is equivalent to n c r, as we sometimes refer to that, but again, it's n choose r, where the combinations of n objects are chosen r at a time. So let's look at our first example here. Number one, how many combinations are there of the set A, B, C, D taken two at a time? So just like we would with permutations, again here, no order. There's no order, we're referring to combinations. So we would do 4 choose 2, or in other words, you could write it as 4C2. Again, that's the same thing as 4 choose 2, which is 4 factorial over 2 factorial, and then 4 minus 2 factorial. Okay, we can also pull this up in our calculator, or we can calculate this by hand. If we did this by hand, it'd be 4 factorial over 2 factorial times 2 factorial, which is simply going to give us 4 factorial over 4, which is 6. Let me go ahead and pull up the calculator so we can go through this just as we would do with permutations. We're going to go to math, go over to PRB, and now you can see we have NCR in there. We first have to select the 4. Again, go to math, PRB, select number 3 for our combinations, and 4 choose 2 is equal to 6. On our second example, we have 6 choose 2. Again, we can practice working this out by hand. So we'd have 6 factorial over 2 factorial, then 6 minus 2 factorial. If we wrote out 6 factorial, we'd have 6 times 5 times 4 times 3 times 2 times 1 over 2, and then we have 4 factorial, and again we can write that as 4 times 3 times 2 times 1. The 4 times 3 times 2 times 1 would cancel, so we'd have 30 over 2, which is simply just 15. And again, we can check that in our calculator by doing 6, going to math, PRB, choosing our combinations, and 2. Part B, now we actually have a variable in there. So we have n choose 3, so that would be n factorial over 3 factorial times the quantity n minus 3 factorial. As you recall, n factorial is equal to n times n minus 1 times n minus 2 times n minus 3, all the way down till we get to 1. 3 factorial will be 3 times 2 times 1. n minus 3 factorial will be n minus 3 times n minus 4 until we get all the way down to 1. And then we have everything from n minus 3 down to 1 is similar, so those would cancel each other out. So in the numerator we'd have n times the quantity n minus 1 times the quantity n minus 2 over 6 as our final answer. And you do not need to factor the numerator out. You can simply leave that in factored form. Look at example 3. A class of 20 persons selects a different committee of 3 each week to take notes and distribute them to the rest of the class. And how many ways can a committee of 3 be chosen from 20 people? So again, couple things here. In how many ways? You'll see this quite frequently because order does not matter here. We don't care who was chosen first on the committee. So if Tom was chosen first, as long as Tom's on that committee, the order doesn't matter whether he's chosen first or chosen last. Okay, so we would do 20, choose 3, and again we can refer back to our calculator. 20, go to math PRB, choose 3, and we get that to be 1,140. Fourth example, how many committees can be formed from a class having 12 girls and 8 boys if the committee must have 3 girls and 2 boys? So we're going to take this first initially by just looking at the girls. If we were just focusing on the girls, we had 12 girls and we're selecting 3, we would do 12, choose 3. And the same idea with the boys. If we had 8 boys and we're choosing 2 of them, that would be 8, choose 2. By the fundamental counting principle, we would multiply those 2 together. Again, using our calculator, 12 choose 3 is equivalent to 220. 8 choose 2 is equivalent to 28, which gives us 6,160 ways this can occur. Moving on to our last example, number 5, we would like to again simplify our combinations here. N choose n minus 1. So in the numerator we'd have n factorial over the quantity n minus 1 factorial times the quantity n minus the quantity n minus 1 factorial. Please notice that I have parentheses around the quantity n minus 1 because we are going to have to distribute through that negative. So in the numerator I'll have n times n minus 1 times n minus 2 until we get all the way down to 1. Please notice in the denominator I have n minus 1 factorial, which is equivalent to n minus 1 times n minus 2 dot 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 all the way down to 1, so I'm going to be able to cancel both of those. And then I'm going to go ahead and distribute through the negative, which would simply just give me n minus n plus 1, so our n's will cancel out. So in the numerator we'll get n over 1 factorial, which is simply just n. So this concludes section 15.3.